Alright, so let's look at a case where we don't know, like we did before, where if this were sine of the inverse sine, that's what we looked at previously, we would just say, well, that's going to come out to 3/5. They undo each other. But since sine and cosine don't undo each other, or cosine and inverse sine don't undo each other, we're going to have to use a different approach. Well, here's what we're going to do. We're going to say, let's say that's equal to cosine some angle theta. Well, that angle theta is equal to the inverse sine of 3/5 then. That must be true. All right. If that's true, we could say that sine of theta must equal 3/5. So all of that uses our knowledge of the inverse sine. If the inverse sine is equal to 3/5, then the sine of theta is 3/5. So let's sketch it. So we sketch the angle. This is theta. And we say, well, we want the opposite, the adjacent, and the hypotenuse. Well, from what we just have, sine is equal to opposite over hypotenuse. So we've got that right here. That's 3 and 5. We can use the Pythagorean theorem and say 5 squared is equal to 3 squared plus, I'm going to use a for adjacent squared. So a is equal, and you can use algebra to get this, 5 squared minus 3 squared, which is 25 minus 9. So then a is equal to the square root of 16, which is 4. So my adjacent is 4. With that in mind, coming back to what we set up here, I can finish the problem and say, well, the cosine is the adjacent over the hypotenuse, which is 4 over 5. So these are a little more involved, and they use all of our knowledge of trig. We had to first of all use our knowledge to rewrite this so that we could sketch a picture. We sketched our picture. We used the Pythagorean theorem to complete our picture. And we went back and finished our problem using the picture. And that's how we approach these problems. Let's look at one more. So what if I wanted to find the sine of the inverse cotangent of x over 2? Now we have a variable involved. But the principle remains the same. If we say that this is the same as sine of some angle theta, where theta is equal to the inverse cotangent of x over 2. That implies that cotangent theta is equal to x over 2. Cotangent is the adjacent over the opposite. So we draw our angle, theta, and we create a right triangle. And the adjacent over the opposite, well, now we can also find the hypotenuse. So the hypotenuse will equal the square root of x squared plus 2 squared. Now, there's not a lot I can do with that, but let's just say that's x squared plus 4. All right, coming back up here now, we can finish the problem. Sine is opposite 2 over hypotenuse square root of x squared plus 4. And that would be my sine. So that's how we'd work through a problem like this one.